There is a machine in Germany that is so large the engineers who built it had to invent new mathematics just to calculate whether the ground beneath it would hold. It does not drive on roads. It does not fit on any road ever built. It moves at the speed of a slow walk, about 10 meters per minute, on a set of crawlers so massive that each individual crawler shoe is larger than a dining room table. It weighs 14,200 metric tons. To put that in perspective, the Eiffel Tower, one of the most recognizable steel structures on Earth, weighs approximately 7,300 tons. The Bagger 293 weighs nearly twice that, and it moves, not quickly, but it moves, under its own power, across terrain, doing work. This is the Bagger 293. It holds the Guinness World Record as the largest land vehicle ever constructed by human beings. Not the largest vehicle currently operating, not the largest vehicle of its type, the largest land vehicle in all of recorded history. And it is not sitting in a museum. It is not a retired prototype. It is working right now in an open-pit lignite mine in Western Germany, doing the job it was built to do, the same job it has been doing since 1995. But the size alone, as staggering as it is not the most remarkable thing about the Bagger 293. What is most remarkable is what it does with that size. Because this machine does not just sit there being enormous. It eats. It consumes material at a rate that seems physically impossible until you watch it happen. And once you understand the scale of what it consumes and why that consumption matters, you will understand industrial foundations. But before we get there, before the bucket wheel, before the conveyors, we need to talk about why this machine exists at all. The reason is more complicated than most people assume, and it connects directly to one of the most consequential energy decisions. Germany sits on one of the largest deposits of lignite coal in the world. Lignite is a low-grade fossil fuel. It is not glamorous. But for decades, lignite has been the foundation of Germany's electricity generation. Cheap, abundant, and entirely domestic. The lignite is there, under German soil, in quantities measured in billions of tons, and extracting it requires moving the earth. Earth measured not in cubic meters, but in cubic kilometers. Moving that overburden efficiently requires a machine of unparalleled scale. The Bagger 293 is the answer. Engineered by Takraf and operating with a productivity that vindicates every decision made in its design. And this is where things get crazy. The number that defines the Bagger 293's productivity is so large, people assume it's a misprint. The Bagger 293 can excavate 240,000 cubic meters of material per day. Read that again, 240,000 cubic meters, every day. In a single operational day, this machine moves enough material to fill approximately 96 Olympic-sized swimming pools. If you loaded that material into standard dump trucks, the kind you see on construction sites, not mining machines, you would need a convoy of roughly 96,000 trucks to carry one day's worth of Bagger 293 output. A convoy of 96,000 trucks, driving bumper to bumper at highway spacing, would stretch for over 1,000 kilometers. Longer than the distance from New York City to Chicago. This is what 240,000 cubic meters looks like. And the Bagger 293 does it every day, not as a peak achievement, as a routine operational output. Now let's talk about the machine itself, because to understand how it achieves this, you need to understand its architecture, and the architecture is extraordinary. The Bagger 293 is a bucket wheel excavator. At its forward end is a massive rotating wheel, the bucket wheel, studded around its circumference with 18 individual buckets. Each bucket is essentially a large steel container with a hardened cutting edge. As the wheel rotates, each bucket in turn digs into the face of the material being excavated, fills with a load, and carries it upward. At the top of the rotation, the bucket passes over a discharge point and the material falls out. The material falls onto a conveyor belt that runs back along the excavator's boom. The wheel then continues rotating. This cycle happens continuously, without pause, 18 buckets in sequence, as long as the machine is operating. The bucket wheel itself has a diameter of approximately 21.6 meters. The wheel is wider than a 6-lane highway. Each of the 18 buckets has a capacity of approximately 15 cubic meters, a load that would fill the bed of a large dump truck. The bucket wheel is mounted at the end of a boom, a long, angled structural arm that extends forward. This boom can be raised and lowered to attack the excavation face, and the entire machine can swing laterally. The conveyor system is itself a feat of engineering. The belt is wide enough that a person could lie across it with room to spare. The total length of the Bagger 293 is approximately 220 meters, longer than 2 football fields placed end to end. Every meter of that length is doing something, carrying material, housing drive systems, or providing structural support. 5 people. That is the operating crew of the Bagger 293. 5 human beings manage the largest land vehicle ever built. The productivity per worker is genuinely beyond any human-scale comparison. And running a machine this large requires a remarkable support infrastructure. The Bagger 293 moves on 12 crawler units, 6 on each side of the machine's main body. Each crawler unit is a self-contained tracked drive system. The crawler shoes, the individual steel pads, are enormous. Each one spans a width that exceeds most dining room tables. The crawler tracks distribute the machine's 14,200-ton weight, so ground pressure is kept within limits that the mine floor can support. This is a central engineering challenge. The Bagger 293 cannot simply sit on unprepared ground without the ground sinking under the load. The mine floor must be carefully prepared, leveled, and reinforced to ensure the crawler tracks have a stable platform. Without that preparation, the machine sinks. If it tilts in an uncontrolled manner, it is a catastrophe with no easy remedy. The drive system is electric. It is connected to the mine's electrical grid by heavy, specially engineered cables that trail behind. The machine consumes electricity at the level of a small city district, effectively acting as a mobile substation. The bucket wheel drive is one of the most powerful rotary drive systems. The motors must overcome enormous cutting resistance. Lignite is relatively soft, which is why the Bagger 293 can achieve such extraordinary throughput. Harder rock would require different methods. The structure must be rigid enough for alignment, yet flexible enough to accommodate thermal expansion in the German climate. Tachraf, the Leipzig-based engineering company, addressed these requirements with a design that has proven its integrity for 3 decades. In 1995, productivity exceeded design specifications. The machine moved more material per day than engineering models had predicted. The Bagger 293's story is not just an engineering story. It is also a story about the choices nations make about energy. The Hambach mine, where the Bagger 293 operates, is one of the largest open-pit mines in Europe. It has been operating since 1978. Over its history, it has produced hundreds of millions of tons of lignite, feeding power plants that generate electricity for millions of German households. At its peak, the Hambach mine covered approximately 85 square kilometers, an area larger than the city of San Francisco. The excavation has descended to depths approaching 300 meters, creating a pit so large that it has its own local microclimate. Wind patterns, temperature gradients, and even precipitation are measurably different inside the Hambach pit than in the surrounding landscape. The scale of the transformation is difficult to process. Forest, farmland, and villages are systematically removed, meter by meter, year by year. The earth and rock above the lignite, known as overburden, are deposited in dump areas that have become visible linear ridges from altitude. The extracted lignite is delivered by conveyor systems stretching for dozens of kilometers to power plants that convert it into electricity for the grid. The Bagger 293 is at the center of this system. It converts solid ground into a stream of material that the rest of the system processes. Without it, the conveyor belts carry nothing. The power plants receive nothing. The grid gets nothing from this source. The Bagger 293 was built to this scale because the economics of lignite mining required high throughput capacity to make the operation viable. A smaller machine would increase labor, maintenance, and infrastructure costs per ton to a level that would make the economics deteriorate. This rationality is expressed in every dimension: the 21.6-meter bucket wheel, 12 crawler units, and the 220-meter overall length. The machine does not just excavate, it is also responsible for the quality of the material, affecting how efficiently power plants can process it. Parameters like cutting speed and swing rate affect the particle size distribution. Operating it correctly requires expertise developed over years. The crew of 5 per shift make continuous decisions about advance rates and system coordination that directly affect the quantity of output. They communicate continuously with ground-level operators and the planning team, operating what is essentially a mobile industrial facility. Standing on the Bagger 293's walkway, the scale is overwhelming. The pit walls descend for hundreds of meters to a distant boundary. Other mining equipment moves across the floor below, dwarfed by the distances. The Bagger 293 consumes the face at 240,000 cubic meters per day. But the story goes beyond mining. The machine exists at the intersection of industrial necessity and environmental consequence. And that intersection has become one of the most contested spaces in European public life. Germany has committed to phasing out coal, including lignite, as part of its transition to a low-carbon energy system. The political and legislative process that produced this commitment was long and contentious. The Hambach mine became a focal point of environmental activism. The ancient Hambach forest became the subject of one of the most prominent environmental protests in modern German history. Activists occupied the forest for years to prevent its clearing. The German government ultimately decided to preserve the forest and adjust the mine's expansion. The coal phase-out legislation established 2038 as the target date for the complete end of coal-fired electricity generation in Germany. At that point, the Hambach mine will cease production, the Bagger 293 will stop working. What happens then to the largest land vehicle ever built is a question that nobody has fully answered. Moving a 14,200-ton machine is not straightforward. Dismantling it in place is possible but expensive. Preserving it as an industrial monument is an idea that has been discussed. The machine is recognized as an engineering landmark of extraordinary significance. Whatever happens to the physical machine, the engineering knowledge that produced it does not disappear. The mathematical models, structural analysis, and drive system designs are available to the engineers who will design the next generation of large-scale equipment. Equipment that may be used not to extract fossil fuels, but to build the infrastructure of the energy transition, like open-pit lithium mines. The Bagger 293 was built for a specific purpose at a specific moment. Those conditions are changing. The machine's purpose may be ending, but the engineering achievement it represents does not expire. It stands as evidence of what is possible when engineers are given a clear problem. The Bagger 293 is the answer to the question of how large a land vehicle can be. In steel, in operation for 30 years. Stand on the ground next to one of its crawler units and look up. The crawler unit alone rises several meters above your head. The bucket wheel boom ends in that 21.6-meter wheel. You cannot see the whole machine from where you are standing. You are too close. We built that out of steel. We built the largest thing that has ever moved on land, and it has been working reliably for 30 years. Next, we move to a machine that doesn't excavate. It doesn't haul. It pushes with a force so extreme, the ground ceases to exist as an obstacle. The Komatsu D575A, the largest bulldozer ever built. Its blade can move more material in a single pass than most equipment moves in a day. The numbers are extraordinary, and we are just getting started.